Hello and welcome to my CIS 212 Visual Basic.NET lecture on Chapter 4, Part 1. It's going to be a multi-part affair. Now, I want to remind everybody before we get going here to always go through and set up your GUI, rename everything, get away from the basic names. Let's start with the form. I renamed it Form Main. I also set the startup position to center screen. That's where I want you to always put that. Where's it at? Windows State. Size group. Oh, my goodness. Just a moment. Well, anyway, it's Windows Start position. I'm not seeing it right now, but it's there. Oh, there it is. Start position. And the default is Windows default location. Always set that to center screen and change the caption here, which is the text property. That's the first thing you do. And after you design your form, whether you sketch it out or play with it on here, these need to have real names. There's label 1, label 2. This is text score 1, text score 2. This is on page 192. I'm doing something similar. It's not exactly what they've got, but I mean, it looks pretty close, but it's not. I started this from scratch. There's button display, button exit, and there's my label output. And they have a solid border on theirs with bold text property, and that's fine. I've just set mine to 3D. It looks a little more current. All right, so what we're discussing here is the second part of the three parts of structured programming. The first one is just sequence, right? You remember this from your logic class. The second one is decisions, right? Or conditions, basically if statements. And there are two types of ifs, which you can remember if you think about it. There's a single alternative if with just an if then and then end if. So you do something if this condition is true, but you don't necessarily have to do anything that's false. It's just depending on what you're doing and what you need. There's the dual alternative if, which has an if then else component to it. So I'm going to go ahead and set up an event, click event handler for my display button. All right, and there it goes. It created it. I just double clicked. You could also go to the lightning bolt under properties and select other events. Okay, so I need a single alternative if. Well, let's just talk about this. I'm going to probably get this wrong anyway because I'm used to doing C#. So there's your keyword if. If some condition is true, then I'm going to do the code associated between the if and the end if. Or if something's false, you can do it that way. X greater than 10. This is meaningless because I don't have, see, it's not going to let me do that. So let me go in here and, because we have all these different settings correct in the compiler, remember? Explicit or implicit off. I forget what they are. There are three of them. Two of them are true, one is false. Dim x equals 10. All right. Dim x as int. It's a totally different declaration than what I'm used to, or what I just did. Oh, so now is x greater than 10? It'll let me do it now. If it is, then we're going to do something else. So see, it stuck the end if in there for me. Unlike other languages, it's kind of loose. C#, C++, Java are a little tighter than this. Okay, if x greater than 10 is true, now remember, if it's a decision, this part here, your comparison, is always going to be a Boolean comparison. In other words, it doesn't matter how much is in there, whether you got ands and ors and nots and all these different things, it's going to evaluate down to one and only one value, true or false. That's why it's called a Boolean comparison. So if whatever I put in here is true, then what's going to happen is any code I put in between these two constructs, the if header and the end if, will execute. All right. This is a single alternative if, right? If I wanted a dual alternative if, I'd have to put the else component in there. That's the false side. So if this is true, we go in here and we do something on the true side. Else, it must be false because Boolean only has one of two possible values. What are they? True and false. 0 and 1. On and off. Yes and no, right? Just that's true and false. So it would come down here and do something. All right, so I'm going to just put a message box in here just for grins, and then we'll get to the actual number swap in a minute. dot show. I just want text. I'm going to put false in there. And then over here, I'm going to put true. Oh, no, excuse me, true. True. Okay. And I'll put false over here. Because this is the false side. All right, so if x is greater than 10, this would evaluate as true, and then my message will say true. Else, x cannot be greater than 10 because this is false, so it's going to display false. So let's run it. See what we get here. Make sure that you take care of these names and the tab orders and all that stuff, because I'm going to start holding you accountable now. We're into chapter 4, so you should be able to do all that. And you do all that stuff first. If you don't, I'm going to start dinging you on points, so just be aware of that. Okay, there's nothing to do in here, so I'm just going to hit display. False. Why did I get false? Because x is equal to 10. It is not greater than 10. So this was false. And so it came here in false side, and it did that. Let's run it again. Yep, that's what it did. So if I come in here and change this and say, is x equal to 10, then it should say true, right? I just changed the comparison in there. And these are logical comparators or comparisons, comparative operators. We'll look at that in a minute. All right, so I'm going to hit display, and it says true because x is equal to 10. So it hit the true side that time. All right, now let's take a look at page 193. What they're going to do here is, regardless of the order in which the user types in the number, you have to deduce which one's the lowest and which one's the highest, because they could put the lowest in score 1 and the highest in score 2, right? So let's see if we can't figure this out. I'm going to do, this is going to be score as double. Let's see, score, I need score 1 and score 2. Sorry, score 1 as double. And we're going to initialize it to 0.0. And then we have another one called score 2. I'm just, that's what I'm coming up with. I'm not even looking at the book. They can do whatever they want. You could, preface this with DBL, because if you look at my naming, that's probably what should be happening here. DBL, what does that mean? It means double. So if you're looking, you or some other programmers looking at this in code, the name tells it it's some kind of a value, like a score for a test score or credit score or something, and it's of type double because of the prefix DBL. Okay, so there we go. All right, so we have that. Now we need to pull the values out of here, and this is text score 1 and text score 2. So we need to grab the values out of that. How do we do that? Well, there's something called the text property, which holds the string inputted by the user or code. So I'm going to have to convert that to what? To double, because that's what DBL score is. And what's the name of it? Text score 1 dot text. Okay. And I do the same thing for the next one. So what I'm going to do here is just copy and paste and then change some things. This will be 2. This will be 2. You just have to be careful when you copy paste, which I'm often not careful. All right, so what we have to do before we display this is we have to decide which one's the highest and which one's the low. Okay? Actually, we probably should have done it like this. High score. Let's do that. Otherwise, it's meaningless. And this will be low score. Slow score. That's the way I feel right now. It's too early. I haven't had my coffee yet, so bear with me. Okay, now we got something we can work with. Now, when we do this, we have no idea which is high and which is low, right? We just don't know. User can do it either way. So now we're about to find out. How you do that? You have to do a comparison, which is why you use an if comparison operation. So according to what they're doing, and they're doing a simple number swap, if score 1 is greater than score 2, because score 1, I suppose, should be, well, that doesn't really make any sense what they're doing. I'm going to do my own thing here because I'm not following why they're doing that. Okay, we're going to just decide, okay? High score is the first one we're going to look at. If DBL, it's not popping up, I wonder why. IntelliSense should have done that. If high score is less than low score, what if they're equal? That's another issue. We'll look at that in a minute. I bet they didn't think about that. If, oh, I see what happened. Okay, if double high score is less than double low score, then we got a problem, don't we? Right? Okay. Don't need this code anymore. Yeah. That's fine. Okay. Master edit. What in the world are they talking about? Yeah, well, I'll figure that out in a minute. I've never seen that one before. Text buffer edit. Let me just save this. I'm going to have to stop this puppy and start over again. Let me clean it. Text buffer. That's insane. All right. All right. I have no idea whether it's saying there's another edit in progress. That's insane. All right. Let me save it. Close it. Open it back up. See if that fixes it. Welcome to the world of Visual Studio. Open. Count. Recent file. Recent projects. That's it. Whoop. Now there. Okay. Never know what's going on with that. Okay, so we've grabbed the high score from score 1 and we grabbed the low score from score 2. We don't know if they're actually in that right order or not, and we're using an if to decide that. So I'm making a comparison using a less than operation here. If double high score is less than double low score, then that means they're out of order, right? So we're going to have to swap them, and I'm going to use a temp variable, a little local variable. Let's see, dim DBL temp, because I have to hold on to one of those. So I'm going to go ahead and set it as a double and put score 1 in there, or double high. All right, let's see. Okay. As double. Syntax is killing me between these two languages. For those of you who are not in both classes, I'm teaching a C# object-oriented class online and a VB class online and a C# C++ face-to-face, so all the differences are getting me. All right, so there's my declaration. I just went ahead and grabbed high score because if this is true, high score needs to be stored somewhere, and low score is actually should be in high score, so I'm just going to do this. Equals low score. Now they're equal, okay? They're both the high score. So what I need to do now is take the low score and put temp in there. That swaps them. It's just a very basic number swap. You can follow the logic, hopefully, at some point. Okay, so that swaps that, we think. Okay, so if they're out of order, do that. Else, now you can nest ifs, right? And you can do it like this. Else if these two are equal, then I need, oh my goodness, I need to do something else. All right, see, that's a nested if. And I keep nesting in different levels and see how it indents. There's a better way to do this. It's called the if-else-if construct. Let me see if I have a space in VB here or not. Don't think I do. I don't need it. I don't need that anymore. And I need an else. Or maybe not. Okay. This needs to be equals. If this is equal to that, then I need to do something else. Okay, if they're not out of order and they're not equal, I don't need to do anything but display it. Okay, so I can just do the display here. We're going to fix this regardless. Now I haven't implemented anything here. Probably need a message box. I don't know how I'm going to handle that. I'm just going to ignore this because they're not doing it in the book. So we'll just assume that they're not going to be. It's too much work. All right, so there we go. And this is just a single alternative if. That's all it is. If they're not out of order, there's nothing to do. Okay. Regardless of what we do, we need to go ahead and output at this point. So I'm going to use the label dot output. Whoops. Dot text. Now I've got the text bolded and centered properties. You know, I did this at design time for that particular label. Equals what? Well, I'm going to have to do some string concatenation here. What does that mean? Remember from your logic class or other classes or other lectures, what that means is you're joining two strings together, and in VB it's an ampersand, and we went through this in another chapter. So let's see what we can do here. I have a string literal that says lowest score, right? Colon space, whoops. And I want to join that together with what? The lowest score, because it's going to be hopefully the lowest score. Now we have to convert it, right? You have to convert it. So I'm going to use convert to. You can do parse, whatever. To dot to what? To string. To string. Okay. And inside that argument list, I'm going to place low score. Now, I want to do a line continuation character in VB. There's no line termination character like there is in C# and C++ and Java and so forth, which is a semicolon. In VB, it's very loose. So if you want to put it on another line rather than have to type way across the screen, use an underscore, which is a line continuation character in Visual Basic. It just allows me to continue that line. So I need another ampersand to join that together. And then I need a control chars. And this is what I like about VB. It's one of the things I like. Control chars. And I want a carriage return line feed or a new line. New line right there. Okay. Now, I need to do another output. Now, I could just go ahead and put all this in one thing, which I may do. I think I will. But I could say label output dot text plus equals and then continue on. It would take what's already in there and then stick something on the end of it. It's like just another way of doing it. So I do another ampersand, and then I'm going to do what? This again, only I'm going to say high score. And I don't need the line continuation character here. This will be highest score. Hope this works. It'll be terrible if it doesn't. I will be embarrassed. It probably won't the first time. I'll probably have to tweak it a little bit. Okay. There's that. All right, let's run this puppy and see what happens. Now, I still haven't figured out how to fix the F10 problem with Camtasia Studio stopping the video when I'm trying to debug. I've got to figure out a way to remap that. Either to remap it in here or remap it in there. I just have to figure that out. I haven't done it yet. I haven't had time, but that's why I'm not doing it. All right, well, let's see what my tab order looks like. Yeah, there you go. So that's pretty good. All right, so they are using 84 and 77. Let's use that. Now, if these are scores, they're going to be doubles, but they're not using a decimal component. Yeah, it works. It works. All right, so let's, I don't have a clear button here. Let's try flipping it around a little bit. 77 and 84. So that should put them out of order. Yeah, it's still working. All right, I did not code my clear button. A pox upon me for a clumsy lout. Let's see. Let's do that. How's that done? What do we use? In VB, it's what? The me pointer dot close. And I think it puts it in there. Yeah, VB's very forgiving. See what it did? It put the little parens in there for me. How nice. Okay, well, that kind of does that. Let's run it again and try flipping those numbers one more time. I don't have a clear on here, so. Yeah, I know some of you probably, like I just did, trying to go over here and run the program. That's why you need to center this thing so it's obvious, because it might stick it right on top of there or close to it. You have to say center screen. You have to set it for the Windows start position for that. Okay, we're going to do 77 and 84. And display. Okay, still works. Exit. Okay. All right, that's part one, and let's see if I want to continue here. Yeah, let's talk about logical operators, and then we'll stop for the second part. Page 197. These are logical operators. Now you have comparison operators, which we already looked at. It's less than, greater than, equal to, less than or equal to, not equal to, right? Now, those sort of like a comparison you use in mathematics or logical comparisons. And then there are the logical operators, which are on the page 197, as I said, not, and also, or else, XOR, or exclusive OR. Okay, not simply flips the logic. If you put a not statement in front of a true, something that evaluates the true, it will flip it to false. That's all it does. It just flips the logic, right? It just reverses it. Okay, and remember your and conditions, right? If you have, let's go in, I'll just do it in here. See if I can't do it down here. The and operator in VB is the word and, okay? You may have like X, well, let's use these because it's going to stick something else in there because I don't have anything declared. If double score is greater than 10, now this is totally meaningless number-wise. It's just an example. I'm using what's already declared, so I'll do it again. And double score is less than or equal to 43.5. All right, this would be inside an if typically, so let's go ahead and do that. If this condition and that condition. All right, now, and then be then. Okay, whoops. All right, so there's my if. If some variable or statement is greater than 10 and some other variable or statement is less than or equal to 43.5, what is an and? What's the rules for an and? Okay, this condition and this condition have to be true for the whole thing to be true, right? So the only way an and can be true is for both of these conditions to be true, the one on the left and the one on the right. One or the other is false, the whole thing is false. So they're both false, the whole thing is false. So the only way an and can be true, because remember this is a Boolean comparison. So this whole thing evaluates to either true or false. Doesn't matter how many ands or ors you have in there, or nots. It's going to come down to one of two values, true or false. The only way this whole and statement can be true is if both this condition and this condition are true. And there's the key to remembering it. This condition on the left and the condition on the right are true. The whole thing is true. Okay. Let's look at an or statement. And then I'm going to get into some of these subtle idiosyncrasies of VB. Legacy issues, as I like to call them. All right, now here's an or. The rule for an or is either this condition can be true or this condition can be true. Then either one of them being true makes this whole thing true. All right, so the only way an or can be false, and see they're kind of backwards, is if both of these are false. All right, so that's the or. And I'm just doing a primer for you. You should already know this stuff. We talked about not and or. Let's look at XOR. This again is on page 197. And these have precedence numbers, as you can see, like order of operations, that sort of thing. I prefer to put parens in there, but I don't like to stack them very deep because it gets kind of complicated. It's not a good idea. XOR stands for exclusive OR, which means only one of the subconditions can be true for the compound condition to be evaluated true. So if I put XOR in here, I don't use this very often, but you know, you can. If both of the, unlike an OR, if both of these are true in an OR, the whole thing is true. With an exclusive OR, only one of these can be true for the whole thing to be true. If they're both true, it's false. Okay, so that's an exclusive OR. Let's talk about short circuit operations. Again, this is, you should remember this from your logic class. Hopefully you took it. It's a requirement unless you're doing some sort of transfer to a four-year school. Let's see, I got my insert key on. All right. When Microsoft, Bill Gates, was throwing together Visual or QBasic for the DOS operating system, they were in a big time crunch, and most good compilers have what's called a short circuit operation. In other words, if you're doing an AND, right, just a plain AND in all other languages, if this one is false, and the compiler knows the rule that both of these have to be true for the whole thing to be true, it will skip the second evaluation because what's the outcome got to be? Well, if they're both have to be true for the whole thing to be true and this one's false, then the whole thing is false. So it doesn't need to look at this one. Now, if this one is true, it does have to look at this one because it could be true or false, and that would dictate the outcome. Same thing with an OR. Now, this is not Visual Basic. This is .NET. This is most all other languages. All right, so with an OR, if this is true, there's no need to look at this one. We know the whole thing's going to be true, even if that one's false. An OR will be true if the first evaluation is true. So that's a short circuit. It speeds up the execution of the code. Now, the original QBasic or Visual Basic does not have short circuit operations. It's going to look at this no matter what the outcome of this is. It's just something they didn't include in the compiler design. However, since they have to support this code out there, this billions of lines of old VB code out there, they had to come up with some, I guess, ways to sort of work around it without breaking that code. So they came up with two new operators. One's called the AND also, see that? Which does do the short circuit operation for an AND. So I typically use AND also all the time. I mean, just to speed things up. You don't have to, but if you don't, it's not going to short circuit. It's going to evaluate both of them, even if it doesn't need to. And then there's OR else. That's an easy one to remember. My parents used to say that all the time. You're going to do this or else, okay? So this short circuits too. If you use a regular OR, it's going to evaluate both of them, even if it doesn't need to. So there's one of the legacy issues right there, as is the ampersand. Because right here, I could have not converted this to a string, and the ampersand operation, when you're talking about string concatenation, would have looked at this. If it wasn't a string, it would have converted it to one. I don't like doing that. That's not something you need to do. You need to always explicitly convert this stuff from one type to another. It's easy to do, and that way there's no mistakes. So there are your logical operations. And on page 199, you can see some truth tables that will show you that. Okay. String comparisons is based on ASCII values, right? The ASCII value for an uppercase A, I think is, I'm guessing 62. And a lowercase a, the decimal ASCII value is 90 something, maybe. Well, if you're comparing 62 to 98, they're not going to be equal. Therefore, if you compare an uppercase a to a lowercase a, they're not going to be equal because they have different binary or decimal values in ASCII or Unicode now. So that's called the, I forget what that's called, ASCII evaluation something. Anyway, there used to be a technical name for it. They've changed it to Unicode so it doesn't apply anymore. Oh, yeah. They used to call it the ASCII collating sequence. Maybe they call it the Unicode collating sequence now. Who knows? I'm not going to test you on that. Anyways, a little trivia there. There's converting strings to an uppercase using the 2 upper and 2 lower method. That's great because, like I say, a uppercase A is not going to equal a lowercase a. If you've got 3 characters like ALA for Alabama or FLA for Florida, the way it used to be, they can type any number of combinations of upper lowercase, right? I think it's 2 to the 3rd in that particular case. So you'd have to have, what, 8 things you would look at? 2 times 2 is 4 times 2 is 8, so it's 8. You'd have to have 8 ifs in order to get all the different combinations. Well, if you just go ahead and use 2 upper or 2 lower on page 206 to just uppercase it, everything temporarily in there, or lowercase it, either way you want, then you don't have to worry about that. It's just one comparison. All right, and you can see that as you go forth. That's something we've already talked about. On page 209, here are some more operators: arithmetic. There's concatenation, comparison, and then logical. Notice that arithmetic operations are more important in the precedence table than some of these other things like comparison and so forth. So if you look at the example down there, you always do the math first because it has a higher order of precedence. So that's you'll see how they're evaluating this out. Just look through the result of the evaluation steps on page 209, figure 4-27. All right, that takes us to the end of our first part of this lecture series, and I will see you again in part